Hello there everyone, and welcome to Bearings with Trigonometry. Here we're going to look at what bearings are and how we can work them out using trigonometry. So let's just pretend then we are in Newport and we are a helicopter pilot. Pretty awesome. Okay, and the helicopter pilot needs to go to Stafford. How would you describe to the helicopter pilot how to get to Stafford? We could say go east, and if you remember your northeast shredded wheat or never ever support wolves, then you will know that to the right is east. So we can say to the pilot, okay pilot, go east. So the pilot would rotate around eastward and then travel eastward, but it would miss it. It's not as accurate as telling the pilot go to exactly Stafford. So how would we tell the pilot to go to exactly Stafford? Well, we'd start by drawing in a north line, or considering that we'll always tell the pilot where to go if the pilot was facing from north. And then we'd say turn exactly 81 degrees around and travel for 15 kilometers and you will get to Stafford. Perfect. That is what bearings are. The bearing is 081, and it's the angle that the helicopter pilot will have to turn from facing north to get to Stafford. So that's what bearings are. It's a direction for helicopter pilots or other people who use survey maps to get from one place to another. So the helicopter pilot will rotate 81 degrees round and then fly 15 kilometers exactly, and they'll get to Stafford. Perfect. What about broods then? Well, the helicopter pilot would have to pretend that they were starting from a position of north, and then they would rotate around 125 degrees and then travel for 19 kilometers to get to brood. So turn around that 125 and then fly for 19 kilometers. What about Telford then? So what we'd say for Telford is we wouldn't say rotate left and then by so many degrees and then travel for so long. We would just give them the clockwise angle going around that direction, and then we'll just say 224, so we don't need to say to the helicopter turn right by 81 or left by 81 to take them in two directions. We'll just tell them the clockwise angle going round. And what I mean by clockwise is I've got a clock up in the top right here, is if you're facing 12 o'clock, it's the angle that you would find when you go in the clockwise direction, or the same way that the clock would turn if it were to turn around the clock. So it'd obviously go in this direction. And then 224 degrees by 11 kilometers. Now, what the helicopter pilot might not do is it might not turn around like that. That might be a waste of time for them. But as long as you're telling them 224 degrees round, and then it would be able to work out what this angle is by doing 360 minus it. You probably turn that way round and then fly 11 kilometers. But you would tell them the number 224 as the bearing. And what about then to get to Wallerton? Well, exactly the same thing. Start from the helicopter pilot facing north, and then it's going to be that clockwise angle going round that will be the bearing. You never say turn left by 52 degrees. It's always a bearing of 308. That way you don't even need to say turn right or turn left. You just shout the number at the pilot, and the pilot can then get there as quickly as possible, because you're just going to shout one number at the pilot, 308 degrees, 14 kilometers, fly. And you don't need to say turn left or turn right to the helicopter pilot. And the helicopter pilot might not do that fancy twirl. It might just work out, okay, 308, that's 360 minus 308, I'll turn left 52 degrees. But that's what you're going to tell the pilot. That's what the bearing is. And that's what we're working on in this video. So, some really important points to do with bearings. To travel from one place to another, pilots will need a bearing of travel and a distance of travel, and we've seen that with the 308 degree bearing and a distance of 14 kilometers. Bearings must always be measured from north, go clockwise round, and be 3 digits. So remember that 81 degree turn? If it was 81 degrees, then the bearing would be a bearing of 081. So that would be the bearing when it's 81 degrees, or 30 degrees it would be 030. So it's always measured from north, and you always go clockwise. Just to really emphasize this, let's imagine another scenario where we have the helicopter pilot. There's it's an ambulance helicopter this time, and there's a patient in Wallerton they need to fly to immediately. So it'll be that 308-degree rotation, fly 14 kilometers to get there, and fly. But once the ambulance helicopter has picked up the patient in Wallerton, the ambulance helicopter needs to fly to the hospital, which is in Shrewsbury. So what the helicopter pilot must do is they must rethink that they're facing from north. Yes, they're facing in the top left-hand direction at the moment, but they're going to be receiving the bearing as if they were facing from north. So the helicopter pilot must always be thinking, okay, when I get this angle of rotation, it's always measured from north. So it's 23 kilometers away, but before the helicopter pilot sees the angle of rotation, it will imagine it's rotating back up to north, then it will get the number of 210 degrees, and then it will rotate round by 210 degrees, and then fly the patient to Shrewsbury. So it's all what I'm trying to emphasize here in this question here is that the angle must always be measured from north, not in the direction that the helicopter has just flown in. It doesn't say, okay, now turn left by 90 degrees and then fly in that direction. It's always a bearing measured from north. Okay, so how would we work out what that angle is and what that direction of travel is? Well, generally, when you've got a map, you've got lots of grid lines on it, the longitudinal lines and the latitudinal lines. And what we can use these grid lines to do is to help us work out how far away Wallerton is and what angle of rotation Wallerton is. So we'll know that Wallerton is 6 of these boxes across, and each of these boxes is 1 kilometre. So it's 6 kilometres across and 5 kilometres up, because that's how many boxes we have on our map here. So 6 kilometres to the left, 5 kilometres up, or 6 kilometres west, 5 kilometres north. Then we could use Pythagoras' theorem to work out the distance, but I'm not really interested in the distance in this video. I'm interested in the angle of rotation. So I'll get rid of those grid lines. In fact, just to simplify the problem, I could even get rid of the map. I could even get rid of the helicopter. So the bare bones of this problem is this little diagram here. From Newport to Wallerton, we'll have a north line at where we're starting from, and then we know we're going left by 6 kilometres and up by 5 kilometres. So how would we work out the angle of rotation? Well, the angle of rotation that we want will start from the north line, and then we'll head round in the clockwise direction until we get to the line that will travel towards Wallerton. So how could I bring in trigonometry into this question to work out what this angle here is going to be? Well, I'm going to bring in trigonometry just to work out this part, because I already know that 3/4 of a turn is 270 degrees. Just a reminder, a quarter of a turn is 90 degrees, half a turn is 180 degrees, and 3/4 of a turn is 270 degrees. So I'm just going to work out this bit here, and then add it on to 270 to get my final answer. So how do I work out x inside this triangle then? Well, think about trigonometry. We have the opposite side over here, and we have the adjacent side over here. So it's going to be O and A, which will be tan. So it'll be tan. We want to find an angle that's tan inverse of opposite divided by adjacent, 5/6. So in the calculator it goes, it's going to be tan inverse 5/6, and we get 39.8 degrees. So that's angle x in here, but that's not the full answer for this bearing. The full answer for the bearing is the whole rotation round from the north line to the distance, to the line that will travel towards Wallerton. So onto this, I need to do answer value, which is 39.8, plus 270 will give me, so it'd be the 30, so it'd be 309.8 0.8, but remember that bearings are just 3 figures, so the answer to this will be 310. So 310 will be the actual bearing for this question, not the 308 that I gave you in the example. Okay, so now that we understand where we use bearings, we're now going to do some bare bones problems relating to trigonometry with bearings. So question 1 here, we'll go through it together. Sarah is 8 kilometres west and 3 kilometres north of Laura. What is the bearing of Laura from Sarah? Okay, so where do I start? I'll start with the first sentence, and I'll ignore the second sentence for now. Sarah is 8 kilometres west and 3 kilometres north of Laura. So because it says of Laura, I'm going to put Laura in the centre of my picture. Then it's going to be 7 kilometres west, so 8 kilometres west, and west is in this direction here. Remember, it's never ever support wolves. So that's how you know which way round it goes. 8 kilometres west and then 3 kilometres north. So 3 kilometres will go north and then that will be where Sarah is. Because it's of Laura, that's where Sarah is in relation to where Laura is. And what I'll do is I'll connect those two together with a line. Now I'll move on to the second sentence. What is the bearing of Laura from Sarah? Okay, so I need to know it's going to be from Sarah. The key bit there is from Sarah. So I'm going to draw a north line at Sarah, and then it's going to be an angle around where Sarah is to get to Laura. Now it's always an angle that goes clockwise round. So round the clock you go. Pretend you're starting at 12 o'clock here, and you're going round the clock until you meet the line that goes to Laura. So it starts going right, and then it hits the line. So I want to work out what this angle here is. How could I work out that angle? Well, trigonometry involves working out the angles inside triangles, inside right angle triangles. So I'm going to work out this angle here. Once I've worked out that angle, I'll realise that the whole line here would add up to 180. So if I know that this angle here is 30, for example, I'll know that this will be 180, take away 30, so it'll be 150. But I don't know what x is yet. So let's work out x first. So it's going to be x equals, I'll have to label my sides first, opposite and adjacent. And then it's going to be O and A, which will be tan. So it'll be tan inverse, opposite over adjacent, 8 over 3. And the answer to that is 69.4 degrees. But the actual answer to the question, that's the angle for x inside my triangle, but the actual answer to the question here is going to be 180 minus answer, because it's the angle of rotation round from north to the line that goes towards Laura. So then 180 minus answer on the calculator. Now round it to 3 figures, it'll be a 111 degree bearing. So there we are, that's the answer to this question. Now you could have done this question slightly differently, but you should always get the same answer of 111. I'm going to do the same question just by doing it slightly differently, and you can choose which way you do it. In fact, sometimes I flick between the two different methods, but it's still of Laura. So Laura must still be in the centre of my diagram. And instead of going west to start with, I'll go north to start with. So north and then west. So it's just a case of doing those two things in reverse. 3 kilometres, 8 kilometres, and that's where Sarah is. Draw the line together, put the north line at Sarah, because we're going from Sarah to Laura. We'll then work out the angle of rotation round, and this time I'll have to work out this angle inside the triangle. So once again, this is the opposite side, this is the adjacent side, so again it's going to be tan. It's not always tan, but in this question it was always tan. Then it's going to be opposite over adjacent, so that's 3 over 8. So tan minus 1 will be 20.6 to 3 significant figures. But this time I don't need to do 180 minus it. Look at how the angle is constructed. It's a right angle and then my angle x. So if it's a right angle then my angle x, then what I'm going to do to my answer this time is do 90 plus answer, because it's going to be a right angle then my angle x. So if I then do 90 plus answer value, I get again 111 degrees. So if you're doing this in class and you're doing it a slightly different method to the teacher and you've still got the same answer as the teacher, then it's absolutely fine. You've probably just drawn your north and west or south and east lines slightly differently to how your teacher has done it, but you should always get the same answer. There'd only ever be one answer to these bearings questions. If you've got a different answer to your teacher, you have done it incorrectly, but don't be afraid if you've used a slightly different method. Okay, let's move on to the next question. So feel free to pause the video, give this one a go if you're feeling brave enough. But here we are. Henry is roughly northeast of Stuart. Okay, before I read anything else, I'm going to put Stuart in the centre of my diagram because it's of Stuart and Henry is northeast of Stuart. So let's remember to never ever support wolves, northeast, southwest. Northeast would be approximately in the up right hand direction, so Henry is probably somewhere up here. Henry is exactly 17 kilometers away from Stuart, so 17 will go here, 10 kilometers of which are northward. Okay, so 10 of those kilometers are northward, and let's join those two lines together like that. Find the bearing of Henry from Stuart. Okay, so it's from Stuart. So that's the key bit in the last sentence. So we're going to start from Stuart. We're going to put our north line at Stuart, and then we'll work out the bearing to move round to get to Henry. Okay, so how are we going to do this with our current diagram? So what I could do is I could work out this angle x inside the right angle triangle, and then I'll take it away from a right angle, the 90 degrees there. So let's work out what we're working with here. We've got the opposite side here, opposite from the angle, and hypotenuse, the hypotenuse of the right angle triangle. So I'm going to be using sine here, so it's going to be sine inverse of opposite over hypotenuse, and I'll do that on the calculator and get 36.0. The next thing I'll do is I'll do 90 minus answer value, and I'll get 53.54054 when done to three significant figures. So remember, it's 0 because it always has three figures in a bearing. Okay, so 054 will be the answer to this question. Let's do the same question using a slightly different method. So I'm just going to draw my diagram slightly differently, but again it's going to be of Stuart. So Stuart will be in the centre of the diagram. And Henry is exactly 17 kilometres in the northeast direction. So here will be Henry, and I'll draw my line up to 10 kilometres and then across to Henry, with the total distance being 17. Find the bearing of Henry from Stuart. So given that it's from Stuart, I'll start my north line at Stuart because I'm going to be starting at Stuart and travelling towards Henry. So my angle will be rotating round clockwise from the north line to meet Henry. So I'll be working out x here, and that would just be my answer. I'll get straight to the answer this way. And this will be the adjacent side on my right angle triangle. This will be the hypotenuse on my right angle triangle. So it's going to be cos, I'm finding an angle, so cos minus 1 of 10 divided by 17. And when I do that on the calculator, I'll get exactly the same answer as I did previously, 0.054 degrees. So we get the same answer both ways, but we've just drawn our diagrams slightly differently. Okay, so your turn to have a go at this question then. Pause the video and give this one a go. Okay, so let's go through the answer. Amy is approximately southeast of Barney. So Barney is going to be where we're starting this diagram. And Amy is approximately southeast. So southeast would be down here. So that would be where Amy is. So she's exactly 15 kilometers away from Barney, 13 of which are eastward. So I'll put that eastward measurement in. And there we are. Calculate the bearing of Barney from Amy. Okay, so it's going to be from Amy. So here we are. There's the north line for Amy. And let's get working this out. So it's going to be an angle starting from Amy, going clockwise round till we get to Barney. So it's this angle that we're looking for here. Okay, well, how am I going to work this one out? I think what I'll do is I'll work out this angle inside the triangle first. And then the whole thing will be taken away from the 360 to make my angle that's going to go round the diagram to meet Barney. So in this question I have the opposite side from the angle. This is the angle, this is the opposite side. This is the hypotenuse, and I'm going to be working out sine inverse 13/15, which on the calculator will give me 60.1 degrees. And then the final answer here for the actual bearing answer will be the angle clockwise rotation round from north, which will be 360 minus answer, which will be rounded to three significant figures, will be 300 degrees as the bearing. So there we are. That's the answer for that question there, 300 degrees bearing. So it's not always the same thing that you have to do at the end to take your angle and work it out into a bearing. It depends on what the diagram's giving you. Okay, and final answer before we move on to the worksheet. Pause the video and give this question a go. Okay, so Carol is approximately southwest of Dave. So Dave is going to be the person in the middle of my diagram. They're exactly southwest, so southwest, sorry. So it's south and then west. So Carol is going to be approximately down here. They're exactly 21 kilometers away, 16 of which are southward. So I'll draw my diagram going southward, 16 kilometers here. Calculate the bearing of Carol from Dave. Okay, so it's going to be from Dave. So Dave is where I'm starting because it's from Dave to Carol. So I'm going to have to rotate round clockwise from the north line to get to the line that will meet Carol. So I think in this question what I'll do is I'll work out this angle inside the triangle and then do 180, add this extra angle. So x here is going to equal, well, this is my adjacent side, this is my hypotenuse, so it's going to be cos inverse of 16/21. So grab the calculator, cos inverse 16/21 will be 40.4 approximately. But the bearing answer here will be answer plus 180, because it will be rotate 180 degrees round, then the extra x angle. So 180 add answer will give us 220 degrees when rounded to three significant figures, or with three figures in there. Alright, so there we are. That's the answer to this question here. So we've got a worksheet now full of 8 questions for you to have a go at. So come out of this video, go into the description of the video, and there'll be a link to a worksheet. Answer those 8 questions, come back to the video, and we'll go through the answer. Alternatively, you could go through them one by one with me right now. So let's get cracking on the first one. I'm just going to keep on going through. You're very welcome to pause the video before I get started on each question as we go through it. So, Freddie is 6 kilometers east and 10 kilometers north of Emily. So now that I know that it's of Emily, I'm going to put Emily in the center of the diagram. And Freddie is 6 kilometers east. So east would be this direction, 6, and 10 kilometers north up here, and this would be where Freddie is. So I'll connect those two together. Find the bearing of Freddie from Emily. Okay, so this will be the bearing, this will be where we start. We start from Emily and we're going to Freddie. So I'll draw my north line there, and then the angle rotating round to get to Freddie. So in this question, what I'll do is I'll work out this angle x inside the triangle, and then I'll do 90 minus it to get the actual answer. So x here is going to equal, well, it's going to have the opposite and the adjacent sides in it, so it's tan inverse, and it's going to be opposite over adjacent, 10 over 6. So on the calculator then, tan inverse 10 over 6, and we get 59.0. But the actual answer to this question will now be 90 minus 59 degrees. So 90 minus answer, which will give me 31. So the actual answer here is 031 degrees. Remember, bearings have 3 figures. If you've got just 2 figures, you put a 0 at the front. So 031 is the answer. Let's move on to the next one. Harry is 11 kilometers west and 13 kilometers north of George. So George is the center of my diagram here. And Harry is 13 kilometers north and 11 kilometers west. So I'll put the west one in first. There's no set way right of doing this. Could have put the north first and then the west one next. It doesn't really matter. So there we are. That's where Harry is. So then the calculation is calculate the bearing of Harry from George. So from George, so I'll start my diagram from George, and then it's going to have to go round clockwise to meet Harry. So what I'll do is I'll work out the angle x inside this triangle here. So it's going to be x equals, I have the opposite side and the adjacent side, so it's going to be tan again, tan inverse of opposite over adjacent, 13 over 11. So tan inverse 13 divided by 11, whoops, and we get 49.8. After doing that, we now know that this is the angle for x. So what I now need to do is take 3/4 of a turn and then add on x. So it's going to be 270, because 270 is 3/4 of a turn, plus the angle I've just worked out, and that will be the final answer. I'm doing answer button plus 270, which will give me 320 degrees bearing when it's rounded correctly. So 320 degrees is your answer to question 2. Moving on to question 3, Loderick is approximately southeast of Kamal. So Kamal will be in the centre of my diagram, and southeast is roughly down here. So this is where Loderick is. So draw that line straight between the two of them. Loderick is exactly 17 kilometres away from Kamal, 11 of which are eastward. So I'll put that eastward line in and draw it downwards. Calculate the bearing of Loderick from Kamal. So it's from Kamal, so I know that I'm going to be travelling from Kamal to Loderick. So northwards will be the line there. Now the angle that I'll work out for the bearing will be this angle going clockwise around from north to the line that will connect to Loderick. So the angle that I'll work out using trigonometry will be this angle inside the triangle. So in this question, x is going to equal, well, it will be the adjacent side and the hypotenuse side, so it's going to be cos inverse of adjacent over hypotenuse, 11 over 17. So on the calculator then, cos inverse 11 divided by 17, and we'll get 49.7. But what is the actual answer to this? Well, what I want to do is, the rotation I want to do is a right angle, and then the angle that I've just worked out. So the bearing answer to this question is going to be 90 plus the answer that I had before. So it's going to be plus 90, which will be 140 when everything's rounded correctly. And that's the bearing answer for this question. Let's move on to the next one. And Morgan is approximately northeast of Nick. So Nick will be in the centre of my diagram. And Morgan will be approximately northeast. So northeast is up here. We'll connect the two with a line. Morgan is exactly 12 kilometers away from Nick, 7 of which are eastward. So what I'll do with this one here is I'll draw my line eastward by 7 and then connect the two together. Calculate the bearing of Nick from Morgan. So I'm going to start up at Morgan this time, and then that'll be my north line, and then it'll be rotating round to get to Nick. Okay, well the angle that I'll work out using trigonometry will be this angle inside the diagram. Then I'll add it onto 180 to get my full answer bearing. So here I'm going to be using the hypotenuse side and the opposite side. So it's going to be a sine inverse calculation. Sine minus 1, the fraction will be opposite divided by hypotenuse, 7 over 12. So typing that into the calculator, sine 7 divided by 12 will give me 35.7. Now the actual answer to this question, that will be this angle x inside the triangle, but I'll now want to add on the 180 degrees to get my full answer as the bearing. So the bearing on this question is 180 plus that 35.7 degrees. So answer plus 180 will give us 216 degrees. And there we are, that's the bearing answer for this question. Let's move on to the next question. Paul is 10 kilometers north and 6 kilometers east of Quentin. So it's of Quentin, so Quentin will be in the center of my diagram, and Paul is 10 kilometers north and 6 kilometers east. So Paul will be up here. Find the bearing of Quentin from Paul. So given that it's from Paul, I'm going to start at Paul and then I'm going to head towards Quentin. So I'm going to go round in this direction here. So the angle that I'll work out using trigonometry will be this one inside the triangle. And then I'm going to do 3/4 of a turn, but then come back by that angle x. So x is going to be, well, that's the adjacent side. This is the opposite side. So it's going to be tan inverse, opposite divided by adjacent, 10 over 6. So it's going to be tan inverse, 10 divided by 6. And that gives me 59 degrees. Now the actual bearing answer to this question will be that 270 degree 3/4 turn, but then come backwards by this 59 degrees. So it's going to be 270 minus answer, and 270 take away answer will give us 211 when it's rounded correctly. So there we are, that's the answer for question 5. Moving on to question 6, Sam is approximately southeast of Ryan. So given that it's of Ryan, Ryan will be in the centre of the diagram. And Sam is approximately southeast of Ryan. So Sam will be approximately down here. Sam is exactly 11 kilometres away from Ryan, 7 of which are southward. And then we'll connect the two together. Find the bearing of Sam from Ryan. So Ryan is going to be where we start, because it's from Ryan, and we're going to head towards Sam. So the helicopter pilot needs to know the angle of rotation from north to get to Sam. So the angle that I'll work out will be this angle here, and then I'll do 180 degrees, and then come back by that amount x. So x here is going to be equal to cos inverse 7 over 11, cos because it's the adjacent and the hypotenuse side, so cos inverse 7 divided by 11, and that would be 50.5. And then the actual answer to this question will be 180 coming backwards by 50.5 degrees, so 180 minus 50.5. So I'll do that calculation, 180 minus answer, and we'll get 130 degrees when rounded to 3 significant figures. Okay, let's move on to the next question. Victoria is 6 kilometres west and south kilometres, so it's 9 kilometres south of Temour. So it's of Temour. So Temour will be in the centre of the diagram, and Victoria is 6 kilometres west and 9 kilometres south of Temour. That would be where Victoria is. Find the bearing of Temour from Victoria. So Victoria will be here. That'll be the north line. So we need to rotate round by this amount to get up to Temour. So this will be an actually easier one. We just need to work out what x is and then do nothing to it. So x is going to be equal to tan inverse, because we have the opposite and the adjacent side. Opposite is 6, adjacent is 9. So the answer to this question, tan inverse 6 divided by 9, will be tan inverse 6 divided by 9, I accidentally clicked tan, 34 degrees. So it would be 034 degrees as the answer to the bearing. And the final question in this video, William is approximately northwest of Xavier. So it's of Xavier, and William is northwest. So northwest will be up here. This will be where William is. William is exactly 10 kilometres away from Xavier, 8 of which are northward. Okay, so I'll put the northward one in there. And find the bearing of William from Xavier. So it's from Xavier, so I'm going to start with the north line of Xavier, and I'm going to rotate round clockwise until I get to my line to go towards William. So the angle that I'll work out using trigonometry will be this angle inside here, and then I'll do 360 minus my angle. So x here is going to equal cos inverse of 8 over 10, because we have the adjacent and hypotenuse sides. So cos inverse 8 divided by 10. And that will give me 37 degrees roughly. But the actual answer to the bearing of this question will be the whole turn 360 degrees coming backwards by 37 degrees, or take away 37. So 360 minus answer will be 323 degrees. And there we are, that's the bearing answer for this question, and that's finishing off the video. So hopefully you've found this video helpful, using right angle trigonometry to work out bearings. Feel free to come back to this video in the future and use it to have a go at some more questions again, and just to check your knowledge is all well and good. Lovely, thanks very much for watching this video. Hopefully you found this useful, and thanks again.